Okay, what we have here are some metalworking files. Whenever you cut or process a piece of metal, the edges get what's called burrs on them. B-U-R-R-S, burrs. And it creates a sharp edge after you cut the metal. You can look right here, there's a big burr right there. And it's a sharp piece of metal sticking out that we need to get rid of to make this piece safe to handle. Not only that, these edges become sharper after you cut them, and you always want to deburr parts and pieces of metal before you do other operations on them, because as you handle them, you could slice yourself open because it is so very thin and sharp. So one thing we use is files. There are many different types of files and shapes. So as you look at this first file, it's a flat file. Do you see the edges cut into that file? Those are actually little blades on the file that are cut into it. Those small blades are cut into the file. It's on both sides also. And the file also has blades on the edges. So as you pick up this file, and here's the handle, right? The end of this part of the file that goes into the handle is called the tang. Then you have the cuts on the blades for the blades of the file. As you can see, this one has a lot of broken spaces in the file where the teeth are broken off. And I'm going to explain why this happens. Because the way these teeth are cut into the file, right, it only works on a forward motion. So when I grab this file and I put it on the edge of the part and I push forward, that is how the file works. If I pull back again, that does nothing to the part except for damage the teeth on the file. And the reason why that is because these teeth that are cut into the file, they're actually leaning forward. So they're leaning forward so that they can take a little cut every time you push the file forward. And because they are leaning forward, they're on an angle forward like this, the teeth. If I pull back against this, and it's going to break the tip off instead of actually biting in and cutting it off, cutting little pieces. So they're very small little blades, and when somebody pulls the file backwards, that's what happens to them, and it breaks the teeth off. So they're only meant to be used on a forward motion. So you push forward, lift, draw back, and push forward again. Now I don't always have to go straight across like this. I can use this file on a cross motion like that, and I can do the whole side at one shot. Notice how I'm holding my finger on top of the file? This is how I can choke up on the file to get a little more control of it. Okay? Instead of holding it way out here. It may be a little harder to control. And you can see it's actually filing the edge on there. You can see the edge, how it's filing it right along the edge there. You can see what's happening to it. This is already done. I don't have to keep going. I'm just showing you how the motion goes. So that edge is nice and filed. The only problem is it pushes that metal over the edge, and now it's actually sticking out on the edge down here, so it still has little burrs sticking out down here. It's nice and flat up here, but it has pushed the metal over to this edge. And we're going to talk about that in a minute, but the first thing you have to do is get the edge on the top all the way across. When you punch the holes out, it also pushes the metal through. So it pushes the metal through and leaves a little burr. So you have to put the file flat on the piece of metal like that and push across it, and you'll feel it when you file it that it actually catches on that burr. So you just put the file flat across like this and push forward across the hole, and it files it down nice and flat. The other reason we need to get rid of burrs is because when you assemble multiple pieces of metal together, whether you're fitting them together and bolting them, or bending all this up and in the corners and bending it all the way around into a shape, those pieces that come together in the bend, those little burrs can interfere and cause a problem. You want a nice smooth surface so that when you bend, it comes together, all the corners come together nicely. So we have to get rid of all the burrs. See, I need to do this part too. See how I'm sticking the file in, all the way in like that, and then pushing out that way? And you can see the edge it makes when I'm done. So you want to go all the way around. This is one part you have to watch. If you're choking up and your hand is on the back side, you might knuckle into the back side. So this is why you have to be careful and watch where your hands are and where the metal is. I don't want to knock my knuckle into the back of this as I'm filing forward, because it could cut my knuckle open. So this is where I'm going to choke back to the handle and use it from the handle. The way I'm filing is I'm almost flat, but then I just lift it up a little like that. So I only have a small angle. I don't have an extreme angle where I'm on the edge like this. I just want a slight angle, a little bit up, so that I'm pushing it off the edge. That's it, and go all the way around. You don't have to do a lot. And then you can feel the top to see if it's smooth. Now this part might be hard, because if I'm going around and I have to do this side, I don't have anywhere to go because I'm hitting the other side of the metal right here in this corner. So I may have to start from the inside this way and push that way. I can go flat against the hole down here, and then I'm going to go this side. See, now this one I have to go this way. And that's it. I should be all the way around. Did I do this corner? I think I missed this corner. Now this top is nice and smooth all the way around. I might want to just do the other side real quick too, just to make sure there's no burrs on it. Depending on how it was cut, in what direction. When I cut on the shear on this edge, it might have been down this way when I cut, and it could have pushed the burr down that way. If I was this way, it would have pushed it down that way. So either way, it depends on what side. So you have to check both sides to make sure you're getting the burrs off both sides. Once you file all the way around both sides, and it doesn't need a lot. You don't need to take a bunch of metal off. You just getting rid of the little burrs. That's it. Nice and smooth now on both sides. But I've pushed the metal across the edge on both sides like this. There is still a burr out here on this edge. We're going to talk about that in a second. I just want to show you the rest of these files. So this file that we just used, flat, both sides, flat file. Okay, and it has cutting blades on the edges too, in case you need to get into a tight space with the file. Flat file. This file is a half round, so it is flat on one side, and then it is rounded on the other side. So could see the blades in it, and it is the same type of file, except this file is double cut. See, there's cuts this way and there's cuts this way, so it's double cut. It'll remove a little more metal for thicker steel or thicker metal projects, but the flat side on the bottom can be used the same way as the regular flat file. It's just a flat file. You can use it for flat parts, flat geometry, okay? The round part would only ever be used for round geometry. Say instead of this 90-degree cutout, it was actually a big round cut. Then I could stick the round edge of the file right into the round geometry and file a rounded part. So that's what round files are for. This file is the same thing. It's a completely round file though, and this one is even good for holes. If there was a hole the size of this file or bigger straight through the part, I could file into the hole, all the way around the hole. So that's what round files are for. This is a square file, so it's basically the same thing. It's just a square, and I can use it on this project, and it may be helpful to like get into smaller areas with the square file. But I could still use it because it's flat on four sides, and I could still use it all the way around. But it's just a different shape that I can use on flat sides. The side of the file you use, the flat edge, should be matching basically the geometry where you're using it on. If you have a round file, it goes in a round area. If you have a flat file, it goes on a flat area. Okay? So that's the files. and then filing this part. And now, like I said before, we have all this burrs on the outside that we pushed over the edges on both sides. Now they're out here. How do we get rid of them? I'm not going to sit here and file across, although I could. I can file across this way. And one way to use these files is actually put them in a vise, put your part in a vise, and then you grab both sides of the file and pull straight back, and that's called draw filing. You can pull straight like this and it will file the edges of your part. But you don't want to do that because it's a really thin piece of metal. If it was a thicker piece of metal, you can do that. This, if we draw filed it, it would just push more metal back out to the both sides that we've already filed. So what we're going to do here with this to clean up the edges is sandpaper. Sandpaper comes in different grits, and what that means is the surface of the sandpaper is got like sand glued to it, right, on the paper. Well, there are different grits. You can see the different texture in these sandpapers. This one over here on the on this side is rougher than this one over here. That's because this sandpaper is 80 grit and this sandpaper is 100 grit. So what that means is across 1 square inch of this piece of paper there are 100 pieces of sand. 100 grit. On this sandpaper, across 1 square inch, there is 80 pieces of sand. So that's why the grit is bigger, is coarse, more coarse on this paper, because the sand, in order to fit 80 of them in one area, in 1 square inch, the sand has to be bigger than 100 grit, where you can fit 100 pieces of sand across 1 square inch. So the smaller the sand, the more area you can fit it in. So I can fit 100 small pieces of sand across 1 square inch here, where I can fit only 80 bigger pieces of sand across 1 square inch on this piece of paper. There are more grits. They go down to 60, 50, 40, and they get like really coarse and gritty. And you do need some of them for some applications where you need to take a lot of metal away. But we're only sanding this really lightly just to get the burrs off. So either one of these is fine. You can even get much higher grit, where it's in the thousands, where it's really almost smooth. It feels smooth, but there's really tiny pieces of sand across that square inch, and it could be up to 2,000 or 3,000 of them in there. Those are for polishing, when you want to polish something to the very, really like mirror finish. So I'm going to take a piece of the 100 grit and I just rip a piece off. And I'm going to take it and I'm just going to rub back and forth. It's not like the file where you can only go forward with the file. The sandpaper doesn't have blades on it, so it's just sand, so you can rub back and forth. So I'm just going to put it on the edges where I need to sand off that edge. Make sure it's nice and smooth all the way around. And I might hit the corners too, if the corners are real sharp. I don't want to have sharp corners, because that corner can get really sharp after cutting it with the shears both ways. It makes a really sharp corner, and it can easily stab you. But you can even see just that little bit of sanding, you can see it got like a little bit round. So sand the corners a little, not a lot, just so they're not sharp. And don't press too hard because you'll push right through the sandpaper. So don't press too hard, just press lightly and rub back and forth until the sharp corner is gone. Go in and all the way around and on the edges, and then it'll be deburred and safe to work with all the way around. You can touch it. It's not going to stay unless you really force it into your hand. It's going to be much safer to work with. Just moving it around, you can feel a lot better. That it's a lot more. And see what the sandpaper does. It scratches it, and it takes a little bit of the metal off, and it makes it safer. Makes the edge safer. We would do this too if there was like rust or something that we wanted to get off of there, or paint. You see what happens as you sand it more and more, it gets shinier. This is what polishing does. You keep sanding and sanding, and it gets shinier. But you can still see all those little scratches in there. See all those little scratches? Now if I took the lighter, a less gritty piece of sandpaper, like a higher number, and did this all again, those scratches would start to go away. And once I got up to a really high number, like 1,000, this would almost look like a mirror after you did it for so long. So that's it, deburring. You have to do this to make your piece safe to work with. And safe for other people to work with.